So the change in L there is also equal to +1. Okay? Tapos, since nag-move siya yung now let's go to our first topic, electronic structure of the atom, where we will discuss first electromagnetic radiation and atomic spectra, followed by quantum numbers and the principles of electron configuration. We will just re-establish and recall the foundational concepts that you have learned in college. Okay, let's go. So, electromagnetic radiation consists of oscillating electric and magnetic fields that are perpendicular to each other and to the direction of wave propagation. Dahil dito, electromagnetic or EM waves can travel through space without a vacuum. So this is your electromagnetic spectrum. Now, the EM waves, they have different wavelengths and frequencies. Tandaan, radio waves and microwaves, they have longer wavelengths and lower frequencies, while X-rays and gamma rays have shorter wavelengths and higher frequencies. Here, dito sa gitna, we see the visible light spectrum, which is just the rainbow, Roy G. diff. Red has the longest wavelength and lowest frequency, while violet has the shortest wavelength and highest frequency. Guys, dapat memorize natin ang EM spectrum, okay? If hindi nyo pa memorize, we have a mnemonic. It's Richmond and Vegas use expensive gadgets. So rich stands for radio, MEN stands for microwave, IN stands for infrared, V stands for visible, use stands for ultraviolet, expensive, yung X stands for X-ray, and gadget stands for gamma rays. So guys, yung mnemonic ito, tandaan, from lowest to highest frequency, okay? From lowest to highest frequency, Richmond and Vegas use expensive gadgets. Okay? As we know, EM radiation carries energy and travels in the form of waves. And this is characterized by the wavelength, which is the distance between two consecutive peaks, yung blue na to, and frequency, which is the number of wave cycles passing a point per second. Now, the amplitude is just the maximum displacement of a point on a wave, let's say dito, from its equilibrium position. So itong malaking arrows na to, it represents the amplitude. Now, based on this equation, the wavelength multiplied by the frequency is just equal to the speed of light, which is equal to 3 times 10 to the power of 8 meters per second. So this relates frequency and the wavelength to the speed of light. Well, now, time to return to some history for us to know how the atom's electronic structure was discovered. Mag-meet and greet muna tayo ng mga idol natin. Oh, hindi mga K-pop ha, hindi to bini ha, syempre, mga idol natin in science. Oops. Guys, kilala nyo ba sino to? Yes, it's Max Planck. So Sir Planck proposed that light is emitted in discrete, specific energy levels na tinatawag na quanta or quantum in singular terms. Through blackbody radiation, na-discover niya ang light is quantized and have discrete or specific values. So guys, tandaan, light is not emitted continuously. Okay? It's in discrete, specific values. Okay? O, sino naman to? Any guess? Yes, it's Albert Einstein. He built on Planck's work on quantized light by discovering that light behaves as a stream of particles called photons through the photoelectric effect. The photoelectric effect served as evidence that light acts as a particle. So let's see, paano nangyayari ang photoelectric effect. So light with a certain frequency and wavelength of 433 nanometers, okay, is being shown on a metal surface. Ito. Here, you see electrons are being ejected or being kicked out from the metal surface, which is the very proof that light behaves as a particle. Now, this equation is the photoelectric effect equation, which describes what happens when light hits a metal surface and kicks out or ejects an electron. Basically, it indicates that the energy of light, ito, E ink, is equal to the energy needed to eject the electron, which is the work function, plus the energy that describes how the electrons move, which is represented by the kinetic energy or Ke. Now, Hv naught represents the work function, while 1/2 mv squared is the formula for the kinetic energy. Okay, summarize na to. Okay, again, this is the photoelectric effect equation. Okay, next. Now, who is this mystery guy? Any guess? Starts with letter D, yung kanyang last name. Yes, it's Louis de Broglie. Hindi de Broglie or de Broglie, it's de Broglie. So he observed the wave-like behavior of electron and light through the double slit experiment. So according to him, a particle such as an electron moving with a momentum and a mass corresponds to a certain wavelength. We will discuss more about the de Broglie equation and the double slit experiment in quantum mechanics in physics. So sum up natin ang discoveries ng ating mystery guys. So si Planck, he discovered that light is quantized. This is represented by the equation E is equal to NH nu, where E is equal to the energy of the photon, H is equal to the Planck's constant, and nu is the frequency. Okay, recall guys, what is the value for the Planck's constant? Oh, so sa manual niyan. Tingnan nyo nga. Yes, it's H is equal to 6.626 times 10 to the negative 34 joules per second. Memorize yan ha? Pati yung units ha? Okay. So this equation just tells us that the energy of each quantum, let's say the energy of each photon, each electron, it depends on its frequency, where higher frequency means greater energy. Now, the variable n represents the different energy levels, where n is equal to 1, 2, 3. So yung n, it is proof that energy is quantized and discrete. Now, the works of Planck and Einstein led to this equation. Light as a wave and particle. So it related the energy of a photon to the wavelength. Okay? Last, we have for electron as a wave. So this was discovered by de Broglie. So the de Broglie wavelength is equal to the Planck's constant over mass times frequency. Okay? Where m is equal to the electron's mass, nu is equal to the frequency, and lambda is equal to the wavelength. This relates the fact that the greater the mass of an electron or a photon, then the shorter the wavelength. Okay? So guys, memorize my equations na to, okay? Because lumalabas talaga sa board exam yung mga ganitong equations. Kailangan mong gamitin ito for solving. With that, we have this first sample problem. So let's answer this together. Rubidium requires 208.4 kilojoules to remove 1 mole electron. Determine the maximum kinetic energy in kilojoules per mole of the emitted electrons when rubidium is exposed to light with a wavelength of 279 nanometers. So guys, ang hinahanap natin dito is Ke, right? So may clue na tayo ng pwede natin gamitin equation is the photoelectric effect equation. Meron na tayong value for the work function. Ito yun, yung 208.4 kilojoules. Kasi tama naman, di ba? Work function is the energy needed to remove or eject electrons. O, anong kulang natin? Yes, it's the energy of the incident light. Di natin alam to. Kaya yun muna yung isa-solve natin through this equation. Okay? So, E ink is equal to Hc over lambda. Ma'am, bakit yan? Kasi may given tayo na wavelength of 279 nanometers. So, let's try to solve together. So, energy of the incident light is equal to the Planck's constant, ito, times the speed of light, ito, over lambda. Now, I converted the lambda from nanometers to meters. Okay? Where 1 meters is equal to 1 times 10 to the power of 9 nanometers. Guys, tandaan to ha. Pag nasa-solve tayo ng equations, kahit ano man yan, okay? I-convert nyo muna lahat in SI units para sure kayo na yung sagot in SI units. Okay? Tip ko yan sa inyo. Para if ever ma-lost kayo sa mga calculations ninyo, sure kayo. Tama yung units. Yan. Okay? Then later on, tsaka nyo na siya i-convert kung kailangan. Okay? So, okay, question. Ma'am, bakit may ganito? Recall guys, energy, ink, basically it means energy of 1 electron. Okay? Energy of 1 photon. Right? Pero kasi, yung hinihingi sa sample problem, removing 1 mole electron. Okay? Again, hinihingi removal of 1 mole electron. That's why we converted it in this way, where 6.022 times 10 to the power of 23 electrons is equal to 1 mole electron. Okay? Again, express it in mole electron. Kasi, yung problem, hinihingi niya per mole. Okay? Sabi din dito. So, the answer is energy of the incident light is equal to 4.29 times 10 to the power of 5 joules per mole electron. Okay? Sana gets so far. Now, we can finally find the kinetic energy through the photoelectric effect equation. Okay? So, KE is equal to the energy of the incident light minus the work function. So, substitute lang natin yung mga values. KE is equal to 4.29 times 10 to the power 5 joules per mole electron minus 208.4 times 10 to the power 3 joules per mole electron. So, convert ko lang yung 208.4 kilojoules to joules. Okay? Again, guys, recall, 1,000 joules equal to 1 kilojoule. Okay? So, we get the answer. KE is equal to 221 times 10 to the power of 3 joules per mole electron or 221 kilojoules per mole electron. Since yun yung hinihingi ng problem. So, the maximum kinetic energy is 221 kilojoules per mole electron. Guys, ba so far? Kaya pa? I know it feels so mahirap na parang complicated na agad. Pero guys, as long as memorize equations and intindihan niyo yung problem, kaya niyo to, okay? Kung mahirap man, it's best na ulit-ulitin niyo ang pag-solve nito. Okay? So guys, so I'll move on. So hydrogen, it is the simplest atom since it only consists of 1 electron. It is key to understanding the quantization of electron and how it moves in different energy levels. Because when the electron moves from a higher energy level, let's say dito guys, to a lower energy level, let's say dito, okay, so this is n is equal to 2, yun dito, it releases light with a specific wavelength. Okay? Because of that, the atom emits energy. Okay? Again, when an electron moves from a higher to lower energy level, emission occurs. Now, when the electron is from a lower energy level, let's say nasa n is equal to 1 siya, then papunta siya na n is equal to 6. Okay? Then the atom absorbs energy. Okay? There is absorption of energy when an electron goes from a lower energy level to a higher energy level. Now, this concept gives rise to the concept of, ano kaya guys? Tama, atomic spectra. It is the specific patterns of light emitted or absorbed by hydrogen atom when the electron moves from one energy level to another. Okay? And an example of this is the hydrogen emission spectrum. So itong figure na to guys is the hydrogen emission spectrum. Okay? Since light is quantized, again, only small specific energies are being emitted, right? Kaya, discrete specific lines lang ang nagre-reflect sa hydrogen emission spectrum. We see here that visible light with specific wavelengths are being emitted, gaya ng light at 410 nanometers, blue light at 434 nanometers, etc. Okay? So, that then gives rise to the hydrogen spectral series. Okay? So, the hydrogen spectral series are groups of lines in the hydrogen emission spectrum, where for each specific series na to, there are electrons dropping to a certain energy level N. Dahil dito, light is being emitted at certain specific wavelengths. So, for example, your red light, it is emitted at 656 nanometers. And this comes from an electron, okay, dropping from the N is equal to 3 energy level, to yun, papunta kay N is equal to 2 energy level. So, this line here belongs to the Balmer series. Okay? So, yan ang concept ng hydrogen spectral series. So, this table shows the various series. Okay? So, Lyman, Balmer, Paschen, Brackett, Font, and Humphreys. So, yung N, it pertains to the final energy level N kung saan mahanap yung electron. So, an electron at a higher energy level, let's say dito, that drops to N is equal to 1, corresponds to the Lyman series. Electron at a higher energy level, dito, that drops to N is equal to 2, corresponds to the Balmer series. An electron at a higher energy level that drops to N is equal to 3 corresponds to the Paschen series. And an electron from a higher energy level that drops to N is equal to 4 corresponds to the Brackett series. Guys, I suggest na i-memorize nyo ang hydrogen spectral series. Okay? And for you to do that, I have a mnemonic for you. It's Land Bank of the Philippines, Bepa Fonha. Ayan. Kung sino papapan dyan? Charot. So, Land Bank of the Philippines, Bepa Fonha. Madali lang i-memorize, right? So, Land for Lyman, Bank for Balmer, Philippines for Paschen, Bef for Brackett, Pafon for Fond, and Ha for Humphreys. Okay? Very easy, right? Now, this table just summarizes the hydrogen spectral series. So, the final energy level for Lyman series is 1. For Balmer series, N is equal to 2. For Paschen series, it's N is equal to 3, etc. So, the region of spectrum, itong nasa third column, refers to the type of radiation being emitted in the series. So, for Lyman series, UV light is emitted. For Balmer series, visible light is emitted. For Paschen, Brackett, Font, Humphreys, IR, and far IR light is emitted. So, the approximate wavelength range is also given here. Okay? Obviously, yung may shortest wavelength ay ang UV, habang ang may longest wavelength naman ay yung far IR. So, guys, I highly suggest na i-memorize nyo din yung approximate wavelength range, just in case lumabas ito sa board exam. Okay? Again, the mnemonic is Land Bank of the Philippines, Bepa Fonha. So now, let's watch this quick video for us to summarize the hydrogen spectral series.
When a transition from higher orbits to the first orbit occurs in the atom, Lyman series is obtained. The values of frequencies obtained in this transition lie in the ultraviolet region of the electromagnetic spectrum. When a transition from higher orbits to the second orbit occurs in the atom, Balmer series is obtained. The values of frequencies obtained in this transition lie in the ultraviolet region of the electromagnetic spectrum. When a transition from higher orbits to the third orbit occurs in the atom, Paschen series is obtained. The values of frequencies obtained in this transition lie in the infrared region of the electromagnetic spectrum. When a transition from higher orbits to the fourth orbit occurs in the atom, bracket series is obtained.
Hey, guys, clear up ko lang yung sinabi kanina sa video. Di ba sabi niya, Balmer series corresponds to UV light, may helium. Dapat, Balmer series corresponds to visible light. Okay? Okay. Now, the Bohr's model, okay, further explains how the excited electrons drop from a higher energy level to a lower energy level in fixed orbits. Okay? With this, makuha natin ang energy ng electron in the nth energy level of a hydrogen atom through the Bohr model. So these are the equations. So the energy of an electron in the nth energy level of a hydrogen atom, where n is equal to 1, 2, 3, and so on, is equal to negative 13.6 over n squared electron volts, or equal to negative 2.18 times 10 to the power of 18 over n squared joules. Okay? So kunwari, yung electron mahanap mo sa n is equal to 2. So you can get the energy of an electron in the second energy level of a hydrogen atom by substituting n is equal to 2 dito, right, sa n squared. Okay? Next, the Rydberg equation calculates for the wavelengths of the spectral lines in the hydrogen emission spectrum as electrons move from a higher to a lower energy level. And this is the equation. Remember guys, yung Rydberg equation, applicable lang siya sa hydrogen and hydrogen-like atoms. Okay? So this is the equation. 1 over wavelength is equal to the Rydberg constant times 1 over n1 squared minus 1 over n2 squared. Okay? So the Rydberg constant is equal to 1.0973 times 10 to the power of 7 inverse meters. And n1 and n2 are the energy levels, where n1 must be less than n2. Okay? So speaking guys, don't you worry dahil discuss pa natin further, and you'll also discuss how to solve problem solving involving Rydberg equation. Okay? So now that we know that the hydrogen emission spectrum describes how electrons transition from one level to another, we must know that electron transitions are either allowed or forbidden. So allowed transitions, mas likely sila nangyayari, while forbidden transitions are more unlikely to occur. So the selection rules determine alin ang allowed or forbidden transitions. So these are the rules. So allowed transitions are only possible for the change of L equals to plus minus 1. Again guys, yung L is the azimuthal quantum number, natatandaan niyo ba po? Kung hindi man, don't worry because we will discuss this later. Okay? So this describes the orbitals, right? Yung S, P, D, F. Dapat plus minus 1 yung change niya. Second, the change in M sub L, the magnetic quantum number, is equal to 0 plus minus 1. For example, lahat ito allowed transitions. 3s to 2p is an allowed transition. Okay? Here, the L is equal to 0, for p is equal to 1. So the change in L is 1 minus 0 plus 1. So that's an allowed transition. Okay? Oh, yeah, sorry. Okay? So guys, from 3s to 2p, pansin nyo, di ba, bumaba yung energy level. From n is equal to 3, naging n is equal to 2. And that's what we call the emission of energy or emission of light. Now, what if, guys, from the transition from 1s to 2p, ganyan, 1s to 2p, so the change in L there is also equal to plus 1. Okay? Tapos, since nag-move siya yung electrons from a lower energy level, n is equal to 1, to a higher energy level, n is equal to 2, then that's what we call the absorption of energy or light. Okay? Guys, sana gets yan. Okay? Kasi lumalabas din yan sa words. Okay? Now, let's move on. Wait on. To the metal ion flame test. Familiar ba kayo dito, guys? So, did you know, flame tests are being used to detect the color of various metals. As you can see here, lithium is reddish-orange, di ba? Tapos si barium green, si copper blue. Ang amazing, di ba? Na nakikita natin yung colors ng mga various metals na ito. Now, the reason for this is that the metal ion flame test show that kapag nag-absorb ng energy ang isang metal ion, na-excite ang electrons nila to a higher energy level. Now, when from a higher energy level, nagbumalik sila sa ground state, they release energy as light, creating a unique flame color. So, ito yun. So, the lithium ion, the radium ion, the strontium ion results in a red flame. For the rubidium ion, it's a red-violet flame. For potassium ion, for cesium ion, it's violet flame. For sodium ion, and for iron ions, it's yellow flame. For calcium ion, it's orange flame, and so on and so forth. Kung lumabas mo nito sa boards, usually tinatanong nila about group 1 and group 2 elements, gaya ng potassium ion, sodium ion, lithium ion, okay? So make sure to memorize this as well. And take note guys, yung pagka-red ng mga different metal ions na ito can be different. Like iba yung hue ng pagka-red nila. Okay? E ganun din kay potassium and cesium. Magkaiba yung hue ng violet or purple flame nila. Okay? So that is the metal ion focus. Okay, we are done with our first part in the Crash Course 1. So mag-checkpoint muna tayo saglit. So, matching type tayo. Okay? Who discovered who? Si Max Planck guys, yung pinaka-first. Ano na-discover niya? Yes, it's the quantization of light. How about Albert Einstein? Yes, it's the discovery that light acts as a stream of photons. Lastly, si Louis de Broglie. Yes, light or electron as a weight. Very good. Okay, so mag-move na tayo sa next part ng ating crash course 1, which is on the quantum numbers. So the atom is made up of a dense nucleus, and it is made up of protons and neutrons. Now the nucleus is surrounded by electrons that move around the nucleus in specific regions called orbitals. So ito yung mga orbitals. Kanina, we learned that electrons absorb or emit quantized energy para makamove siya in between energy levels. So these energy levels are described by quantum numbers, which define the allowed energies, shapes, and orientations of electron orbitals. So the quantum numbers describe the position and energy of the electrons in an atom, as shown in table 2. First is the principal quantum number n, which pertains to the electron's main energy levels or shells. It generally describes the distance of the electrons from the nucleus. I-indicate din ito na there are only specific and allowed values of energy level n because energy is quantized, sabi nga ni Planck. Next we have the azimuthal quantum number L, which describes the energy subshells and the shape and type of the orbital. So the value of L can be from 0 to n-1. The types of orbitals na dinedescribe ng L quantum number are the S, P, D, F orbitals, wherein each of them have different L values and shapes. Third is the magnetic quantum number M sub L, which describes ilan ang orbitals found in a subshell. It also describes the possible orientations of the S, P, D, and F orbitals in space. So the allowed values for M sub L is from negative L to L. Lastly, the spin quantum number, or M sub S, describes the movement of the electron. Okay? It can be from clockwise or counterclockwise. So the allowed values for spin quantum number is negative 1/2 and 1/2. So ito yung sinasabi nilang spin quantum number. Ito 1/2, ito negative 1/2. Okay? Let's proceed. Now, orbitals are regions of space where we can find the electrons. The orbitals are described as S, P, D, and F, where each of them has a distinct shape and orientation. So kindly refer to this table or page I4 of your manual. First, when L is equal to 0, it refers to an S subshell. There is only one S orbital, and it is spherical in shape. And its magnetic quantum number, M sub L, is just 0. So ganito siya. Ganyan. Isa lang yung orbital niya. Next, for L is equal to 1, it refers to the P subshell, which has 3 orbitals. Ito. These are dumbbell shaped. So you can see here, and their orientations are given by M sub L equal to negative 1, 0, plus 1. So ko yan, ganito yung orbitals ni P. Negative 1, 0, plus 1. Then, for L is equal to 2, it refers to the D orbitals. So 5 yung D orbitals. And they have clover leaf shapes itong blue na to. And their magnetic quantum numbers, M sub L, is negative 2, negative 1, 0, positive 1, positive 2. So ganito yung orbitals. 5. Negative 1, 2, negative 1, 0, positive 1, positive 2. Lastly, for L is equal to 3, we have the F subshell with 7 orbitals, which are more complex and spread out. So ito, more spread out. Diffuse ang F orbitals. Okay? They have the magnetic quantum numbers, negative 3, negative 2, negative 1, 0, 1, 2, 3. Okay? So, sana gets yan, guys. Well, very kaya pa, di ba? Yeah. So let's watch this quick video to know more about the quantum numbers.
The Schrödinger equation helped our understanding of electrons. Rather than pinpointing an exact location, the equation allows us to map out the electron densities as well as determine its quantized energy level. And solving these electron densities are how we get atomic orbitals, which are 3D regions of space where electrons are most likely to be found. Each orbital can host up to 2 electrons, and these orbitals only exist if they are occupied by electrons. They are energetically favorable locations for electrons, so finding an electron outside these orbitals is highly improbable due to electron energy constraints, but it's not impossible. The behavior of electrons in these orbitals is described by 4 quantum numbers. The principal quantum number n is any positive integer, so for example 1, 2, 3, 4, etc. And it indicates the electron's energy level relating to its distance from the nucleus. This concept was initially introduced in the Bohr model, so these distances represent principal quantum numbers. The next is the angular momentum quantum number, or L, ranging from 0 to n-1, and it determines the orbital shape. An L value of 0 describes the s orbitals, 1 for p orbitals, 2 for d orbitals, and 3 for f orbitals, each with different shapes and configurations. So if n was 2, you could have 0 or 1, but not 2 or higher, because remember, it's n-1. The magnetic quantum number, m sub L, which can be any integer between negative L or positive L, specifies the orbital's orientation. This number relates to the possible configurations of each orbital shape. For example, s orbitals where L equals 0 only have 1 configuration, so m sub L equals 0, whereas p orbitals where L equals 1 have 3 configurations, where m sub L can equal negative 1, 0, or 1, and so forth. Lastly, the spin quantum number, m sub s, which is either positive half or negative half, represents the electron's spin direction. This aligns with the Pauli exclusion principle, ensuring no 2 electrons in an atom have the same set of quantum numbers. Now, let's look at some quantum numbers. For n equals 1, the simplest level, we encounter the 1s orbital. Here, L equals 0, and m sub L is also 0, indicating it's a spherical orbital with room for 2 electrons of opposite spins. It's the lowest energy orbital, making it the first to be filled. Moving up to n equals 2, we have 2 types of orbitals. The 2s, where L equals 0, and 2p, where L equals 1. The 2s orbital, similar to the 1s orbital, has a spherical shape, but the 2p orbitals are more complex, with m sub L values of negative 1, 0, and 1, each capable of hosting 2 electrons. At the n equals 3 level, things expand further. We see the 3s orbitals, where L equals 0, and the 3p orbitals, where L equals 1, with 3 possible configurations. Here, the orbitals increase in size and energy, but we also encounter the 3d orbitals, where L equals 2, which represents 5 unique configurations, reflecting more ways electrons can be arranged. For n equals 4, the orbitals look even weirder. Electrons can occupy the 4s, 4p with 3 configurations, 4d with 5 configurations, and finally 4f orbitals, which have 7 configurations. The sequence in which these orbitals are filled is guided by the Aufbau principle, a topic I'll delve into in the next video. So in essence, these four quantum numbers form a framework for understanding the states of electrons in all atoms. This understanding is important in chemistry as it helps predict how electrons change states and interact, which in turn influences molecular bonding and properties. So for instance, we can predict that two hydrogen atoms will bond due to the compatible orbital symmetries and energy levels. And compatibility of orbital symmetries and energies very simplistically describes much of how chemistry actually works and happens. But in reality, large molecular structures, orbital distortions, and system energies have to be considered, which is why it's not just as easy as saying these symmetries are compatible, therefore these molecules will bond. Nonetheless, it provides an invaluable foundation for understanding atomic and molecular interactions in chemistry. So that's about it. Thank you for watching.
Okay guys, so let's stop here. Then let's proceed to our discussion. Kanina, we learned that orbitals are the 3D regions of space where electrons are likely to be found. So again, this is the s orbital, this is the p orbital, and this is the d orbital. Again, maximum number of electrons sa isang orbital ay 2 lang dapat. Okay? Then the orbital does not exist if there is no electron occupying it. Again, kanina, we learned that for n is equal to 1, there's only one possible azimuthal quantum number L, which is L is equal to 0. And that corresponds to 1s orbital. So nag-iisa lang ang orbital for an s subshell. And the shape of the s orbital is spherically symmetric, like this. And the designated magnetic quantum number for that is equal to 0. Okay? Recall guys, the m sub L represents the possible orientations of the orbitals. For 1s, isa lang ang possible orientation. For n is equal to 2, there are two possible azimuthal quantum numbers. It's L is equal to 0 and L is equal to 1. So for L is equal to 0, it corresponds to the 2s orbital. Guys, 2s siya kasi n is equal to 2. L is equal to 0, kaya s siya. Okay? It corresponds to this shape, where s sub L is equal to 0. Now for the L is equals to 1, it corresponds to a p subshell. Kaya tinatawag natin siya 2p orbital. And there are three different orientations for the p orbital. Ito, ito, and ito. And each of them is designated a magnetic quantum number. -1, 0, and 1. Okay? Kayang-kaya guys, right? Okay, so let's proceed. Now, this figure summarizes the relationships between the shells for n, subshells for L, and orbitals. So guys, here's a technique. The number of present subshells within a shell is just equal to the shell number. For example, for n is equal to 1, the only possible subshell is S. Isa lang. For n is equal to 2, there are two possible subshells, S and P. For n is equal to 3, there are three possible subshells, S, P, and T. For n is equal to 4, there are four possible subshells, S, P, T, and T. Second, orbitals within a subshell depend on the orbital type. So we have 1 orbital for S, 3 for P orbital, 5 for D, and 7 for F. And guys, again, the electrons within an orbital must be 2. Take note that at n is equal to 5 and below, not all subshells are needed to accommodate electrons. Okay, for n is equal to 5, it can fill the 5s, 5p, and 5p, and 5f starts to fill within the actinides. Then for n is equal to 6, it fills the 6s, 6p, and sometimes 6d orbital. Lastly, for n is equal to 7, it fills the 7s and 7p orbitals. Okay? Now, as shown in table 3, okay, the principal quantum number n corresponds to the first, second, and third, and so on, energy level, right? And each of them has a corresponding L values. Again, guys, L must be equal to 0 to n-1. Next, table 4 shows that we can calculate for the sum of orbitals and electrons in a shell n and subshell L. So the total number of orbitals in a shell is equal to n squared. For a subshell, it's equal to 2l plus 1. For the total number of electrons in a shell, it's 2n squared. And for the total number of electrons in a subshell, it's 2 times 2l plus 1. So for example, we want to know how many orbitals are there in the 2s orbital. For 2s, okay, the subshell is what? L is equal to 0, right? Kasi s yan. So let's solve. 2 times 0 plus 1 is equal to 1. So there is one orbital in 2s, which is tama naman, diba? How about the total number of orbitals in a shell? So the shell here is given by n is equals to 2. So it's just 2 squared. No? So the number of orbitals in the n is equals to 2 shell is equal to 4. Next, for the total number of electrons, we use these equations. For example, again for 2s, the subshell, okay, again s means L is equals to 0. So 2 times 0 plus 1 is 1 times 2. So there are 2 electrons in the s subshell. Ayan. Lastly, the total number of electrons in the n is equals to 2 shell. Okay, so that's 2n squared. That's 8. So there are a total of 8 electrons in the n is equals to 2 energy. Okay? So for table 5, we see the number of nodes in an atomic orbital. So what are nodes? The nodes are regions within the orbitals where the probability of finding an electron is exactly 0. So ito yun guys. Yan. Ito mga white na to. Okay? So there are two types of nodes. First is angular nodes, which is related to the shape and orientation of the orbital. Second is the radial nodes, which pertains to spherical shells with 0 probability. So to get the angular nodes is just equal to L, the azimuthal quantum number. Radial nodes is equal to n minus 1 minus L. And the total number of nodes is n minus 1. So that's just angular plus radial nodes. Okay? For example, we want to get the number of angular nodes for a 3D orbital. Since angular nodes is equal to L, then let's find the L of 3D. For D, that's L is equal to, yes, it's 2. So there are 2 angular nodes. For the radial nodes, so n minus 1 minus L. N is equal to 3, so n 3 minus 1 minus 2. So that's equal to, ilan yan? 0, tama. Lastly, for the total number of nodes, that's n minus 1. So that's 3 minus 1 equal to 2. Okay guys, sana clear yun? Again, that's 3 minus 1 equal to 2. Very easy, right? Kaya-kaya nyo i-memorize. Now, we have another sample problem. Okay, try nyo muna sagutan guys, okay? Okay guys, let's answer. So, determine whether the following sets of quantum numbers are allowed based on the rules of quantum mechanics. So for the first row, let's answer that. N is equal to 3, tama naman. L is equal to 0, tama rin. Okay, so with this, we can assume that the orbital for this set is 3s. The m sub L is equals to negative 1. Oops, mali yan. Why? Because the s orbital, yung f sub L yun, ay 0 lang. Okay? Remember, isa lang yung possible orientation ng s orbital, and that is 0. It cannot be equal to negative 1. So, the first set is not allowed. So, second set, n is equals to 1. Okay, pwede. L is equals to 1. Oops, mali yan. Bakit? Again, L must be equal to 0 to n minus 1. Since 1 minus 1 is equals to 0, then L should be equals to 0. Okay, so the second set is also not allowed. Guys, dapat clear to ha. I hope clear to sa inyo. If you have any questions, feel free to ask me. Kasi laging lumalabas yung mga ganitong types of board exam questions. And I know na kayang-kaya niyo yan sagutan. Diba? Now, let's move on to our second topic, the electron configuration. So, the electron configuration of an atom provides the arrangement of electrons in the orbitals of an atom in a way that maximizes its stability. So, it is based on how the four quantum numbers identify an electron na nasa orbital ng atom. So, this is how we visualize the electron configuration. Okay? So, we can fill up these orbitals, yung mga naka-box. So, per box is one orbital. Tapos, ang pag-fill up is in increasing energy. So, for example, we first fill up the 1s orbital siya kasi yung may lowest energy. So, remember, in one orbital, there must be a maximum of 2 electrons. So, you fill up this orbital first before you move on to the higher energy level, which is 2s. So, fill up mo muna yan before ka mag-move on kay 2p. So, fill up mo muna to. Again, single muna guys, okay? Single muna, bago, double. Ulit, after you finish this, punta ka na sa next energy level kay 3s. So, ganyan. Tapos, punta ka kay 3p. Again, single na lang. Tapos, double. Ganun. Okay? Later on, makikita pa natin yan. Now, this figure shows the arrangement of the electron configuration. Guys, dapat memorize natin ang arrangement ito, okay? Important ito. I remember nung nag-board exam ako noong 2023, may related question on electron config. So, I started ginawa ko, sinulat ko to, as in itong figure na to, para sure ball ang sagot. Madali lang naman siyang sundan. Ito, turuan pa yun. So, ginawa ko, memorize in rows. So, 1s, 2s, ganyan. Di ba kanina sabi ko, yung shell number is equal to the number of subshells available sa kanyang shell. For example, kay 1s, yan yung first row mo. Ang only subshell lang niya ay s, isa lang. So, 1s, mag-isa lang siya. For n is equals to 2, there are 2 subshells available. S and p, kaya dalawa na siya. 2s, 2p. Then for n is equals to 3, there are 3 possible subshells, S, P, and D. So tatlo na siya, 3s, 3p, 3p. Then for n is equals to 4, hanggang n is equals to 7, 4 ang possible subshells, S, P, D, and F. So susulat nyo lang siya by row. Diba? Sobrang easy. Tapos, i-draw nyo lang yung diagonal arrow. From right to left na diagonal. Ganyan. Okay? So erase ko muna. Tapos yung order, yung sequence ng electron configuration in increasing energy is like this. So 1s, 2s, tapos 2p, tapos 3s, tapos 3p, tapos 4s, tapos 3d, 4p, 5s. Okay? Again, yung direction nito is in increasing energy. Okay, di ba madali lang siya? Pero kung nahihirapan pa tayo dyan, don't worry guys, dahil meron ako mnemonic para sa inyo. Ayan. First, ginagawa ko, yung numbers muna memorize natin. Okay? So this mnemonic just shows the correct sequence of the electron configuration. Okay? So from left to right, tapos pababa. Okay? So let's start with the lowest energy, 1s. Okay? Then look at the numbers closely ha, yung naka-black. Okay? So first row, 1, 2, 2, 3, 3. O di ba madali lang yung sagutan? Madali lang yung i-memorize. So 1, 2, 2, 3, 3. Next, let's go to the second row. 4, 3, 4. Tapos 5, 4, 5. Oh, that's very easy, right? Observe the alternating patterns. Next, 6, 4, 5, 6. 6, 4, 5, 6. O, diba? It's also alternating. Next, 7, 5, 6, 7. Diba? Alternating din. And lastly, 6, 7, 7. O, yung last, napakadali nang i-memorize yan. Okay? Again, 1, 2, 2, 3, 3. Tapos 44, then 5, 4, 5. Then 6, 4, 5, 6. Then 7, 5, 6, 7. Then lastly, 6, 7, 7. Diba? Kayang-kaya niyan. O, tanong nyo, what if? Orbitals naman, ma'am. Paano i-memorize yan? Parang hirap naman yan. Don't worry, dahil madali lang yan. O, sa first row muna tayo. For the SEDF orbitals, okay? Si Sam, pumasok sa pinto. Next, sa door pinto, sa door pinto. Sa front door pinto, sa front door pinto. Front door, front. Di ba? Ang galing. O, ulitin natin yan, ha? Sabayin nyo ako. Okay, kahit nanonood lang kayo. Para ma-memorize yun na agad. Hindi nyo na kailangan balikan. Okay, go. Si Sam, pumasok sa pinto. Sa door pinto, sa door pinto. Sa front door pinto, sa front door pinto. Front door, front. Oh, di ba? So, yung mga starting letters ng mga mnemonic na yan, okay, represents the orbitals S, P, D, F. Okay, clear, guys? Actually, guys, pwede rin yung Sam, pwede siyang si Sally, si Susie, yung pinto pwedeng Party, yung D pwedeng Daddy, yung F pwedeng Frankie or Francis. Pwede naman, guys. Depende sa version nyo. Pero ito yung simplest. Kung hindi nyo pa alam to. Okay? Di ba? Kayang-kaya. Ulitin nyo ha, sa inyong sarili ha. Okay. Now, let's proceed. Now let's take a look at the electron configuration of elements 1 to 10 and the filling of electrons for each. For hydrogen, it's 1s1. Makita niyo sa right, yung orbital diagram. So this is how you fill it. For helium, it's 1s2. May dalawa ka ng electrons. So you just fill the 1s orbital. Okay? So from single, naging double na siya. Diba? For lithium, 1s2, 2s1. So first, fill the 1s orbital kasi siya yung lowest energy. Then the next orbital, which is 2s1. Yan. Then carbon, ganun din. 1s2, 2s2, 2p2. So 1s muna. Yan. 1, 2, 3, 4, 5, 6. Guys, ha, tandaan, single muna bago double. So single. Okay? For nitrogen, ulit 1s2, 2s2, 2p3. So 2, 4, tapos 7. Kasama diba? Kasi 7 din yung electrons ni nitrogen. Sa oxygen naman, 1s2, 2s2, 2p4. 1, 2, 3, 4, 5, 6, 5, 6, 7, 8. O guys, ha, tandaan, single muna bago kayo mag-double. Okay? Ang last yan is neon, which is a noble gas. 1s2, 2s2, and 2p6. As you can see, filled na ang 2p orbital niya. Okay, guys? Guys, may napansin ba kayo dito? Diba, yung mga atoms na ito, they are arranged as is in the periodic table. Kaya this shows that the periodic table is designed to match the order of electron filling. Papakita ko sa inyo. Here is our periodic table. So the elements in the periodic table are arranged in a way that their electrons fill orbitals from lower to higher energy levels. Para lang sumusunod ng isang base, then yung destination mo is yung atom. So here guys, n is equal to 1. Tapos ito 2, 3, and so on and so forth. Okay, so then muna ako Hydrogen, 1s1. Helium, 1s1, 1s2, right? 1, 2, 1s2 for helium. Lithium, 1s2, 2s1. Beryllium, 1s2, 2s2. Boron, 1s2, 2s2, 2p1. Diba? Kay carbon, 1s2, 2s2, 2p2. Diba? Kayang-kaya, diba guys? Na parang titignan mo lang yung periodic table. O paano naman kay iron? Dito si iron. Sige, sundan nyo ako sa maze ha. Kunwari nasa likod ko kayo. Okay. So hydrogen, 1s1, 1s2, 2s2, 2p6. Okay. Kaya yung 2p6 na to. 3s2, 3p6, 4s2, then 3D, 1, 2, 3, 4, 5, 6. Yan, 3D, 6. Diba? Kayang-kaya. So, ang electron configuration ni iron is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. So, 1, 2, 3, 4, 5, 6. Okay? Tandaan, this refers to the D block. Okay? Tapos ito naman, P block. And ito naman ang S block. Nandito yung F. Okay, guys? I hope that's clear. Yeah. So, clear ko muna to. So, these are the following steps in finding the electron configuration of a. So, here in our example is potassium. Step 1, identify the number of electrons in the atom. So si potassium, ang atomic number niya ay 19, so it has 19 electrons. Step 2, fill the orbitals starting from the lowest energy level. Guys, again ha, from lowest to highest energy level, yung pag-fill ng orbitals. And if you fill yung orbitals using the 19 electrons. Step 3, each orbital holds a maximum of 2 electrons with opposite spins. Okay, so for example, the 1s, 1, 2, 2s, 1, 2. So each orbital, yung box, okay, contains 2 electrons. Step 4, with orbitals of the same energy, place 1 electron in each orbital before pairing them. Okay, so iko-complete ko na yung 19 dito, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, observe nyo guys, naglagay mo na ang tig-isa sa bawat orbital before pairing them. Okay, so single, 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 double, double, double. Okay? Then, sunod sa PS, so far we have 12, 13, 14, 15, 16, 17, 18, 19 electrons. Right? Now, we can determine the full electron configuration by listing the filled orbitals in order. So ito na ang electron configuration. Oops, yan. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Now, we can also use the noble gas shorthand notation. So, guys, hanapin nyo lang sino yung noble gas before potassium. Tingnan nyo nga sa periodic table. Yes, it's argon. That's why the noble gas shorthand notation is argon 4s1. Okay? Guys, ito yung tinatawag natin inner electrons. Okay? Again, ito yun. And this inner electrons has the same electron configuration as the argon noble gas. Okay? Now, ito naman, yung ating valence orbital. Okay? Valence or outermost. Okay? So siya, yung nandito na electron. Guys, tandaan nyo ha, kasi magagamit natin to the future. So the valence electrons are used in chemical bonding between atoms. Okay? Okay. So sana get so far. Let me clear this up lang. Okay. Yeah. So how we fill electrons depend on various principles, as shown in table 7 or page I5 of your table. First is the off-bow principle. It states that the orbitals are filled with electrons in increasing energy. So 1s muna, bago 2s. Next, the Magnus rule. The orbitals with lower n plus l value are filled first. So, tingnan natin n plus l for s versus 3d. For s, 4 plus 0, because l is equal to 0 for s, so 4. For 3d naman, 3 plus 2, because d has l is equal to 2, 5. So, si 4s ang may lower n plus 10. So, siya ang mafe-fill first. Okay? Next, the Hund's rule. So, the most stable arrangement of electrons in subshells is the one with the greatest number of parallel spins. Okay? So, ganito, dapat parallel. Okay? Mali ito, guys. Ito. Ito, guys, hindi ito parallel. Okay? Hindi yan parallel. Okay? And mali din ito. Let's say, okay? Kasi mas gusto ng stable arrangement na parallel. Okay? And lastly, the Pauli's exclusion principle states that an orbital must contain a maximum of 2 electrons with opposite spins as shown here sa 4s orbital. Okay? Hence, no 2 electrons can have the same set of quantum numbers. For example, ito kasi guys, itong mga electrons sa orbital na itong 4s, they have the same n, l, and m sub l. Ang hindi nila same is m sub s. So ito, yung naka-up na arrow, m sub s niya is 1/2. And yung nakababa naman, m sub s niya is negative 1/2. Okay? That's why no 2 electrons can have the same set of quantum numbers. Guys, memorize nyo ito kasi lumalabas lagi sa board exam ang principles governing electron configuration. And for you to memorize that, I have a mnemonic for you. Oh, my hotdog pala. So, ao means off-bow, my, madalong, hotdog, Hund's rule, and pala means Pauli's exclusion principle. So, yung dalawang A dyan, guys, sa pala, okay, means 2 electrons na hindi pwede same ang set ng quantum numbers. Okay? Okay, ao, my hotdog pala. Let's proceed. Now, let's compare ground state versus excited state briefly. So, ground state, guys, okay, represents the lowest energy arrangement of electrons, while the excited state refers to any allowed higher energy arrangement, for example. Here we have the sodium atom. So, yung ground state electron config ng sodium is 1s2, 2s2, 2p6, 3s1. As you can see here, na-excite yung electron ni sodium, let's say from n is equal to 2s na electron, dito sa 2s, pag nag-absorption ng light or ng energy. Okay, so that electron here will go from the n is equal to 2 energy level papunta sa n is equal to 3 energy level, resulting in this figure on the right. Kaya nagkakaroon ng excited state ang isang atom. So the excited state electron configuration is 1s2, 2s1, 2p6, and 3s2. Okay? So yan yung difference nilang dalawa. So for ions, such as sodium ion or potassium ion, same rules apply, pero dapat i-take into account natin ang electrons lost or gained. So for sodium atom here, we know that its electron configuration is 1s2, 2s2, 2p6, 3s1. Okay? Or neon, 3s1. Again, yung valence electron niya is 3s1. However, for sodium cation, okay, meron kasi siyang +1 charge. And ito ang nangyayari. There is a loss of 1 electron in its valence orbital. Ito yung valence electron mo, yung nasa 3s orbital. Mawawala yan because you have a +1 charge. That's why the electron configuration for sodium cation is 1s2, 2s2, 2p6, or neon. Okay? So, masasabi natin na same ang electron configuration ni sodium cation and neon atom. In relation to this, okay, species with the same electron configuration or same number of electrons are isoelectronic. So, example na natin dyan, yung neon and sodium cation kanina. Okay, they are isoelectronic because they have the same electron configuration of 1s2, 2s2, 2p6. So, other examples of isoelectronic species is magnesium cation. So, tingnan natin, ang magnesium cation kasi, yung valence orbital niya is 3s2. Now, the magnesium cation, it has 2 plus 2 charge. So, it has to lose 2 electrons. So, mawawala yung 2 electrons ni magnesium sa valence orbital niya. That's why, yung magiging electron configuration ni magnesium cation is 1s2, 2s2, 2p6. Okay? Next, for nitrite and iron naman, so si nitrogen kasi, its electron config is 1s2, 2s2, 2p3. Now, nitride ion has a negative free charge. So, it gains 3 electrons. So, plus 3 tayo dito sa valence orbital ni nitrogen. So, 3 plus 3, 6. Kaya magiging electron configuration ni nitride and ion is 1s2, 2s2, 2p6, which is the same as the neon atom and the sodium cation. So, other isoelectronic species include for 2 electrons, 1s2, electron configuration. So, the isoelectronic species are hydride, helium, and lithium cation. For 18 electrons naman, the electron configuration is 1s2, 2s2, 2p6, 3s2, and 3p6. And the isoelectronic species are fluoride and ion, argon, and potassium cation. Lahat ito ay may same electron configuration na ito. Okay? Hope that's clear. Yeah. Bilis na lang guys, kasi review na lang to, right? Okay. So once again guys, Aufbau principle states that the orbital should be filled with any electrons in increasing energy. However, may mga exceptions para dyan, and these include the elements listed in table 9. So from the left side of the table, okay, chromium, molybdenum, gadolinium, and curium are exceptions to the Aufbau principle kasi preferred nila half-filled yung valence orbital sila. Ganito kasi yung mukha ng half-filled guys. 1, 2, 3, 4, 5, d orbital. Okay? That is very stable kasi symmetric yung electron distribution and there is minimized electron-electron repulsions. So for example, for chromium, kung hahanapin talaga natin yung electron configuration niya, ang lalabas is Ar, 4s2, 3d, 4. Ganyan. Okay? 1, 2, 3, 4. Guys, isang electron na lang para maging half-filled and stable siya. That's why yung electron sa 4s orbital will jump to the d orbital. Okay? Para mas maging stable yung electron configuration ni chromium. Now, for fully filled valence orbitals, that's also stable. Ganito yung mukha niya. Ayan. Okay. So, symmetric yung electron distribution and minimize din yung electron-electron repulsion. Super stable na guys ng ganitong electron configuration. It's like, perfect na orbital. Okay? So, for example, for copper, pag hinanap kasi natin manually yung electron config niya, it's gonna be 4s2, 3d9. Guys, isang electron na lang para maging fully filled siya. That's why yung electron sa 4s will jump to the d orbital. Okay? Hope that's clear. So, memorize it into guys, okay? Kaya niya. Yay! So, malapit na tayo matapos. So, may sarili akong branding ng slides, guys. Okay? Summary slides na to. Diba? Parang malapit na yung Pasko, no? Namamasko na agad, no? Okay. So, these are the quotes or parang cue cards. So, here we summarize all that we have learned in this crash course video. First, electrons fill the lowest energy levels first before moving to higher ones. What principle is that? Yes, Aufbau principle. A way of showing how electrons are arranged in an atom's orbitals, that's electron configuration. The lowest energy state of an atom, where all electrons are in the lowest possible energy levels. Tama, ground state. Electrons fill empty orbitals of the same energy one at a time before pairing up. Anong tawag dyan, guys? Ulit? Tama, Hund's rule. Okay? Atoms are ions that have the same number of electrons and the same electron configuration. Tawag dyan, guys. Isoelectron. Next. Regions around the nucleus where electrons are most likely to be found. Tama, orbitals. No two electrons in an atom can have the same set of 4 quantum numbers, and only 2 electrons can be in one orbital, and they must have opposite spins. Pauli exclusion principle. A number that indicates the main energy level or shell of an electron in an atom. Ang tawag dyan, madali lang yan? Yes, principal quantum number n. A set of numbers that describe the position and energy of an electron in an atom is quantum numbers. Lastly, the electrons in the outermost shell of an atom that are involved in chemical bonding. Tawag dyan, guys? Tama, valence electrons. So this is a summary of our equations in the electronic structure of the atom lecture. Okay? So guys, save nyo na tong table na to for reference. And this is our review checklist. Yung mga mnemonics na ginamit natin kanina. For EM radiation, it's rich men in Vegas, use expensive gadgets. For hydrogen spectral series, it's Land Bank of the Philippines, BEP of Hanha. Electron configuration, natatandaan niyo pa ba to? Kung si Sam, pumasok sa pinto. Sa door pinto, sa door pinto. Sa front door pinto. Sa front door pinto. Front door front. Okay? Lastly, electron configuration principles. Oh, my hotdog pala. Yay! So we are done with Crash Course 1. Congratulations, guys! Now, time to answer Inorganic Chemistry Practice Test 1. So, meron siyang 10 items and you can answer it for 15 minutes. Then, you can now move on after that to the Crash Course 2. Okay? Okay, guys. Hopefully, tapos na kayo magsagot ng inyong Practice Test 1. Congratulations. Now, let's move on to Crash Course 2. So, for now, we will learn atomic properties. So, we will learn effective nuclear charge, atomic radius, ionization energy, electron affinity, electronegativity, metallic property, and the exceptions to the periodic chain. Gina? G! Okay, let's go! Guys, recall from your bridging course that you discussed periodic table. Now, we will explore in depth the periodic table, the periodic trends, and how it explains the properties of bonds. So, the main basis of periodic trends is the effective nuclear charge. So, the nucleus, yung nasa gitna, it attracts electrons through electrostatic force. Okay? Now, the inner electrons dito sa loob feel the stronger pull, while outer or valence electrons experience weaker attraction to the nucleus. Now, bakit? The weaker attraction is because the inner electrons cancel and shield some of the nuclear charge being received by the valence electrons. Okay? Because of this, the effective nuclear charge on ZEF or the CEF measures this net attraction and is used as a basis in explaining periodic trends. So guys, basically, pabida-bida kasi yung mga inner electrons na yan. Okay? Sinishield nila yung attraction ng nucleus sa outer electrons. Okay? To know more about effective nuclear charge, let's watch this video. Okay?
Today, we're going to learn all about nuclear charge, shooting effect, and effective nuclear charge because we will be using these concepts to explain the trends and variations in atomic radius, ionic radius, first ionization energies across a period and down a group, and the successive ionization energies, so do stay tuned for my upcoming videos. Firstly, let's talk about nuclear charge. As the name suggests, nuclear charge refers to the positive charge of the nucleus because of the positively charged protons that's inside of it. The positively charged nucleus will attract the negatively charged valence electron towards itself, which causes a contractionary effect on the atom. Hence, the strength of the nuclear charge depends on the number of protons present in an element. So when the number of protons in an element increases, the nuclear charge increases, and this in turn causes the electrostatic force of attraction between the nucleus and the valence electrons to increase, thereby making the atomic radius smaller. On the other hand, The shielding effect in an atom has an expansionary effect which causes the atomic radius to become bigger. This happens because the electrons in the inner shells repel the electrons in the outer shells, hence forming a shielding effect which prevents them from experiencing the full effect of the actual nuclear charge. Both the shielding effect and the nuclear charge are occurring at the same time, and the combined expansionary and contractionary effect is what we call the effective nuclear charge, which is given by the formula effective nuclear charge equals to nuclear charge minus the shielding effect. So if the nuclear charge is greater than the shielding effect, the effective nuclear charge increases and there will be a net inward force of attraction between the nucleus and valence electron, as it is stronger than the shielding effect between the electron shells.
Okay, now we know the concept of effective nuclear charge.
Today,
Now, let's discuss the trend for effective nuclear charge. Down the group, the effective nuclear charge, almost constant lang. We would expect, diba, na may increased nuclear charge down the group kasi mas marami yung number of protons, diba? Kasi nag-increase yung atomic number. However, this is not the case kasi na-offset din ito ng more inner electrons sa shells. Okay, again, mas dumadami din kasi yung inner electrons as you go down the group. This is why the effective nuclear charge cannot explain the periodic trend down the group. Across the period, the effective nuclear charge increases because mas maraming protons in the nucleus that increases the nuclear charge and its attraction to the outer electrons. Now we know that there is more protons across a period kasi increasing ang atomic number. We can quantify the effective nuclear charge through this equation, where the effective nuclear charge is equal to the atomic number Z minus the shielding constant S. Now, the shielding constant represents how the inner electrons cancel or reduce the attraction between the nucleus and the electron of interest. So it accounts the shielding effect, sabi nga kanina, right? So a higher effective nuclear charge means a stronger attraction between the nucleus and the electron. Now, the Slater's rules are used to determine the value of the shielding constant. It is calculated based on the proximity of the inner electrons to the electron of interest. Okay? So kunwari, meron tayong electron of interest dito. Dito, kita niyo yung red niya. Ayan. Yan yung electron of interest nyo. Now, electrons that are closer to the nucleus, kunwari dito, may mga electrons ka dyan, contribute more significantly to shielding constant. As you can see, 1 ang contribution nila. While those na mas malayo sa nucleus, or those on the same shell as the electron of interest, kunwari dito na shell, and -1 shell, okay, they contribute less to the shielding constant, 0.85. Okay? Don't worry guys, ulit pa kayo. We will do this step by step. So, how do we compute for the shielding constant S? Step 1, we group the electrons based on N, or increasing energy. So guys, recall your electron configuration lesson, okay? So we just group them based on N, 1s, 2s, 2p, 3s, 3p, 3d, ibang group yan guys ha, 4s, 4p, 4d, 4f, 5s, 5p, 5d, and 5f. So remember nyo lang guys, ang S and P groupmate sila lagi, pero yung D, yung F, naka-individual sila, okay? Ayan. So step 2, compute the shielding constant based on the sum of electrons per group multiplied by their contributions. So yung contributions ito is this, given by this table. So the electrons in the higher orbitals and the electron of interest are not included. Okay, for example guys, yung electron of interest nyo, okay, yung hinihingi sa isang problem belongs to the 1s group. Okay, then ang contribution ng other electron na sa same 1s group na yan is 0.30. Okay, what if naman ma'am, nasa NSNP group siya, yung electron of interest. Now yung other electrons na nasa same group na yan, 0.35 ang contribution. And if nasa ND or NF group naman ang electron of interest, 0.35 ang contribution nila. Okay guys, I hope that's clear. Okay, so don't worry kasi isa-isahin na natin sa ating sample problems. So first sample problem, calculate the effective nuclear charge of a 1s electron in neodymium atom. First, we determine the atomic number of neodymium, which is equal to 60. Usually guys, yung step 1 dito, hanapin talaga natin yung full electron configuration. Pero since 1s lang naman yung hinahanap guys, 1s, yung electron of interest, so hindi natin kailangan yung other electrons na outside of the electron of interest. Tandaan nyo pa guys ha, yung kailangan nyo lang for the shielding constant is yung other electrons na sa same group ng electron of interest and other electrons na mas malapit sa nucleus. Okay? That's what guys. That's why, for step 1, 1s2 lang yung nakalagay. Okay? Again, walang effect sa shielding constant yung electrons outside of the electron of interest. So here, we have one electron of interest, right? Dalawa, yung 1s electrons natin. So yung other electron, okay, has a contribution to the shielding constant. Since 1s group, yung other electron, okay, na nasa same group, 0.30 yung contribution ng electron na yun. So let's calculate the shielding constant. S is equal to the 1 electron from the same group as the electron of interest times 0.30 yung contribution is equal to 0.30. Calculating for the effective nuclear charge, F is equal to Z minus S. So 60 minus 0.30 is equal to 59.70. So that's your effective nuclear charge. Diba guys, napakalaki ng Zef nga. This is expected from an electron, a 1s electron, that is very near to the nucleus. Kasi syempre, 1s siya ang pinakamalapit sa nucleus, right? Okay. Sana get so far, very easy pa yan, diba? Now let's move on to number 2. Calculate the effective nuclear charge of a 5s electron in strontium atom. So this is found in your manuals. So first, we find the atomic number, okay? So the atomic number is equal to 38. Tingnan lang sa periodic table. Next, you write the full electron configuration of strontium. Full ha? Okay, so that's this, okay? Now, step 1, group nyo muna yung electron configuration based on increasing energy. So 1s2, groupmate sila, 2s2p, groupmate sila, 3s3p, groupmate sila, 3d, groupmate, individual, 4s4p, groupmate, 5s2. Kasi siya lang naman talaga mag-isa, wala ka namang 5p dito, di ba? Okay, so your electron of interest ulit is a 5s electron. Isang electron from the 5s orbital. So, yung other electron in the 5s orbital contributes to the shielding constant. So, it's an electron in the same group. Now, may effect din sa shielding constant ang electrons in n-1 group. Since n is equal to 5, then n-1 is equal to 4. So 4s2, 4p6, sila yung electrons in n-1 group. And the rest of the electrons here, sila naman yung electrons in n-2 or lower groups. Guys, itong black na nakabox, itong blue na nakabox, and itong red na nakabox, may iba silang contributions to the shielding constant. So, calculating for the shielding constant, guys, refer na lang kayo sa table, okay? So, the shielding constant is equal to 1 times 0.35, kasi 1 electron from the same group ang nag-contribute sa shielding constant, plus 8 times 0.85, 6 plus 2, 8, plus times 0.85, ito yung contribution sa n for n-1 group. And 28 electrons, so 2, 4, 10, 12, 18, 28 electrons in n-2 or lower groups times 1, that's equal to 35.50. That's your shielding constant. Yeah, for your reference, guys, okay? Tama, diba? 0.35 for the same group. Here, 0.85 for n-1 group. And 1, yung contribution ng electrons in n-2 or lower groups. Okay? So the value of the effective nuclear charge is equal to atomic number minus shielding constant is equal to 38 minus 35.15 is equal to 2.85. The effective nuclear charge of a 5s electron in strontium atom is 2.85. What can you observe? The electron in the 5s atom has a low effective nuclear charge. 2.85 lang kasi yung electron, malayo na siya sa protons in the nucleus. Nasa n is equal to 5 energy level na yung electron eh. Diba? Also, napakaraming electrons below n is equal to 5 ang nag-shield ng attraction ng 5s electron sa nucleus. Okay? Napakarami ng electrons sa n is equal to 4, napakarami ng electrons sa n is equal to 3 and lower groups na nagko-contribute sa shielding effect. Kaya mababa ang ating effective nuclear charge. Okay? Okay, last, calculate the effective nuclear charge of a 3d electron in iron atom. So, the atomic number for iron is equal to 26. And here is the electron configuration. Okay? So guys, dapat marunong na tayo dyan, okay? Step 1, we group it based on increasing n. Yeah. So guys, yung ating electron of interest is, yes, 3D, nandito. Okay? So meaning guys, ito, X na yan ha, wala siyang effect sa shielding. Right? Kasi, outside siya ng electron of interest. Okay? The inner electrons will affect the shielding constant. Now, isang electron lang naman ang iniinteresan natin dito kay 3D. So yung 5 electrons na natitira sa 3D orbital contributes to the shielding constant. Then, all of these guys, yung 1s2, 2s2, 2p6, 3s2, 3p6, they are considered as electrons in n-2 or lower groups. Okay? And they have a different contribution in the shielding constant. Ma'am, bakit? Parang hindi naman yun nakalagay sa table. This is because for a 3D electron, guys, okay, 3s and 3p orbitals are considered as inner to 3D. Kaya 1-matic ang contribution ng electrons ng 3s and 3p orbitals. Okay? Tandaan nyo to guys ha, if ang electron of interest nyo ay nasa nd orbital, gaya ng 3D, the electrons in the ns and np orbital contribute 1 each to the shielding. Okay? So now, let's calculate for the shielding constant S. So, we have 5 electrons in the same group. 5 times 0.35, yung contribution nila, refer to your table, plus 18 electrons. So 6 plus 2, plus 6 plus 2, plus 2, that's 18 electrons, times 1, lahat ang contribution nila. Okay, 1 ang contribution nila sa shielding constant. That's equal to 19.75. Calculating for the effective nuclear charge is equal to atomic number minus shielding constant, 26 minus 19.75 is equal to 6.25. Okay, guys, I hope that's clear. Okay. So now let's move on to the next periodic trend. Watch this video first on atomic ages.